Hello everyone and welcome to lesson 3.2 where we are going to have the privilege of learning about corrosion cleaning and corrosion prevention. So in the last lesson we talked about corrosion, what it is, the chemical relationships that make that happen, and here are a few images from the last time. Essentially what happens is that there are four conditions that exist to have any type of corrosion. You have to have an anode, which gives away electrons. You have to have a cathode, which accepts the electrons, which very often on aircraft comes from two dissimilar metals, such as a titanium bolt on a piece of steel or something like that. You have to have electrolytes. That's essentially something that conducts the electrons from the anode to the cathode. Something like maybe the water, the moisture in the air in the atmosphere, salt. Deposits, dirt, grime, and there also has to be electrical contact. So to protect against these four risk factors, the simplest solution is to essentially add protective layers that avoid that from happening. Let me show you a video that gives you a better visual on that.
If you cannot avoid using materials with different electrochemical activity, then somehow you need to prevent these processes from happening.
For that, you can apply a coating on the metals to block the compounds that would take part in the reactions. Another option is to add an insulating layer between the two metals, so that electrons cannot pass through it, and as a result, the reactions cannot take place.
So, protective layers. You may be wondering what specific protective layers you should add. Well, it depends on the situation, depends on the kind of metal that you're using. Let's get a little more into that. So, to start off, let's talk about aluminum. Aluminum's a very common fuselage metal, especially in some older aircraft. Both allodyzing and anodizing are two separate processes that can be used on aluminum. Allodyzing is a chemical treatment that basically puts a protective film layer on a part, and anodizing is an electrical chemical process where essentially panels of aluminum are dipped in a chemical solution that is electrified, and it basically creates a protective anodic layer on the top of the aluminum. It's more expensive, but it is very effective. If you want to learn a little bit more about the allodyne process and the anodizing process, I have two videos that I'm going to include later in the Nearpod if you're listening to this on Nearpod. If you're doing this by Google Slides, I also have the videos embedded as well. But the bottom line, why do we care about allodizing and anodizing? Like the previous slide said, we need to have a protective layer, and allodizing and anodizing can act as a protective layer for aluminum that essentially protects aluminum from electrolytes that can cause corrosion when all the other elements are in place. We also have another thing you should know as well. When you're cleaning the surface of an aircraft, and you happen to have oil on it or grease, soap and water is your best solution. And very often what you're going to end up doing after you clean it with soap and water is do what's called a water break test. Basically, you pour water on it to take a look and see if the water beads up. If it beads up, there's still dirt, grime, or oil, and if it doesn't bead up, then the surface is clean. Again, dirt and grime, you don't want that to stay on the plane. It can erode at protective layers, and we know all about protective layers. Protective layers protect against corrosion. Got a couple videos embedded for you. If you're doing this via Nearpod, I'll include those as well. Magnesium. There is a number of magnesium parts that you'll find on an aircraft. As you learned in the previous lesson, it's very anodic, which means it's extremely corrosive. It means it has the potential to be corroded. So for that reason, there's special procedures that need to go on with magnesium parts. First of all, it needs to be cleaned with a commercial solvent that's decarbonized, scraped, or grit blasted. Additionally, when removing corrosion from a magnesium part, you need to use a stiff hog bristle brush. The reason why they're so specific about the bristle brushes is because if you use a metallic brush, your metallic brushes are usually made out of cathodic material, and if you have anodic magnesium and they're together, what's going to end up happening is that it could corrode any magnesium part if the right circumstances prevail. I've got a couple of questions for you. Why don't you go ahead and knock those out? Let's move on. So, engine cylinders and tubing, something else that's really important to know. Structural steel tubing should be coated with linseed oil to protect against corrosion. Engine cylinders that are not activated and run regularly can quickly develop corrosion due to environmental elements. So again, we got to make sure we're protecting, we got to make sure that we're running our engines regularly. But if you have to put an airplane in storage and you don't intend to run the engine for a while, then you need to seal the cylinders with a corrosion preventative mixture. So that way this doesn't happen. And if once the mixture has been applied and you do that, you cannot rotate the crankshaft, because doing so will cause the cylinders to rotate, which will break the seal and cause the elements to get into your cylinder and cause corrosion. Got a couple quiz questions for you. Let's knock them out. All right, let's move on. So, caustic products. A few things you should know. If you ever see the word caustic hanging around, it means corrosive. So, you already know about corrosion. I think this pretty well applies, but bottom line, caustic materials can erode at the protective layers and allow corrosion to happen. You don't want that. Fade surfaces. So we talked about fretting in the previous lesson, and the idea is that you have tight-fitting surfaces like plates and rivets, for example, but there's still the possibility that material can get in the microscopic gaps at a riveted seam or at any other tightly fitted surface, and if corrosive materials sneak in, they can be entrapped and cause damage on these fade surfaces. So again, we got to make sure that while you're cleaning, if you use anything that's caustic in your cleaning, you got to make sure you cover up the rivets so that way you don't have any corrosion of fade surfaces. Why don't you go ahead? Let's knock that question out. Let's move on. So, hydrogen embrittlement. Okay, this is an interesting chemical phenomenon you should know about. Here's the deal. Believe it or not, there's a lot of hydrogen in cleaning solutions. And if you use unapproved cleaning compounds, you could unwittingly introduce hydrogen into the metal surface of your aircraft. Why is this bad? Well, hydrogen basically can break down the chemical structures of metals. You have hydrogen, and hydrogen is actually cathodic. It has one valence electron, and essentially electrons have a tendency, like you can see in this diagram here, to want to travel to it. Thus you have galvanic action breaking down the surface right here. So again, using only approved cleaning solutions is critical to avoiding hydrogen embrittlement. And again, I didn't define this super well, but hydrogen embrittlement means that when you introduce hydrogen to the surface of a metallic structure, it can cause it to become brittle. So again, we don't want that to happen. Use the approved cleaning solutions, because by not doing so, you introduce cathodes into a situation that otherwise could become very galvanic. We've got a quiz question for you. Let's knock it out. Let's move on. So cleaning and painting. So a couple important pieces of information for you. Before you paint, surfaces should be cleaned and wiped down with aliphatic naphtha, which is a chemical compound. And when using chemical cleaning agents and paint stripper, you've got to make sure you're using cotton wiping cloths instead of synthetic. The reason for this is that synthetic tend to be more flammable, and in addition, they have a tendency to cause static electricity buildup, which could cause a spark, something you don't want to have happen on your plane. Aliphatic naphtha is important for cleaning surfaces before painting, but it's also important for cleaning acrylics and rubber, particularly your tires. Very important. Using the incorrect cleaning materials could erode protective layers. We got to make sure we use the right materials. Got a couple quiz questions for you. Let's knock them out. Let's move on. So, plastic surfaces. Something you should know about plastic surfaces is that when you're wiping a plastic surface with a dry cloth without having it previously wet, it could cause scratch marks. Don't do that, especially on the windows. Not a good idea. So you always want to start by flushing the surface with clean water and soap and then wiping the surface clean. Let's go ahead and knock out the final quiz question.